Hey guys, I'm back with a new video. In this video, we will start to understand the sklearn library in Python along with Pandas. I may do a complete crash course on both of these libraries in future. So this is the 19th video of our machine learning series. In the previous video, we'll learn about the naive Bayes classification algorithm along with the concepts of probability required for its understanding. Till now, all the implementations that we did for various algorithms were completely based on the concepts that we learned. We wrote the entire code from scratch. Let me introduce you to a library that was made for machine learning analysis to make our lives easier, and that is Scikit-Learn. So Scikit-Learn, you can say, is a module that comes bundled with all of the functionalities required to make your machine learning models in under 2 to 3 lines. So you can think of it like a black box where all of the functions that we defined while implementing various algorithms have already been implemented in Scikit-Learn, and you just have to import them in your code and you're good to go. So in this video, let us create our naive Bayes classifier, and together with that I will also create the KNN classifier to show you how easy it is to create a simple machine learning model using Scikit-Learn compared to the complete implementation of KNN algorithm that we did in our video of KNN. If you haven't checked out the video on KNN and the intuition video on naive Bayes classifier, the link for both the videos can be found down below this video. So back in my Visual Studio Code, the agenda for this exercise is to introduce you to two of the most heavily used Python libraries for machine learning and data analysis, namely Pandas and Scikit-Learn. Now the Pandas library helps us in easy handling and manipulation of data. You can refer the basic tutorial on getting started with Pandas. The link for that can also be found down below, though I will be making a Pandas in one video in the future as well. So let us get a brief overview of the Pandas library. So first, let us import the required packages. So I can say import pandas as pd. Now coming to Scikit-Learn, it helps us to easily import the machine learning algorithms that have already been implemented under the hood of the library, and you can directly use them. So Scikit-Learn library helps us in easily applying already implemented machine learning algorithms to our dataset. Now the Scikit-Learn library has tons of modules, and in this video we are going to use the naive Bayes module for the naive Bayes algorithm. And I will also show you an extremely simple KNN implementation compared to the one that we wrote from scratch. So we have the neighbors module in the Scikit-Learn library. And now for computing our performance evaluation metrics, we don't need to write all that code which we wrote in previous videos from scratch. We can directly import the metrics module from your Scikit-Learn library, and then we are good to go. So let me show you how we can apply Scikit-Learn library to our iris dataset. Now to learn about all of the modules present in the Scikit-Learn library, feel free to check out the official docs. The link for them can also be found down below. So let us import everything that we need. So I can say from Scikit-Learn .naive Bayes import Gaussian naive Bayes as naive Bayes, and then from Scikit-Learn dot neighbors import kneighbors classifier as KNN. And now from the metrics module of the Scikit-Learn library, let us import precision score, accuracy score, and recall score. So I can say from Scikit-Learn dot metrics import precision score, accuracy score, recall score. So now to load the dataset into memory, we can make use of the read CSV function from Pandas because our dataset is in CSV format, which is iris.csv as you can see here. Now to experiment with an extensive list of all the input-output functions Pandas provide, you can check out the link for the Pandas documentation, which can be found down below the video. So here I can say data pd.read CSV. Now from the Pandas module, we can directly use the functionality read CSV, and here we can specify the CSV file that we want to read and specify the header names. So first column represents sepal length, second one represents sepal width, third column represents petal length. The fourth column represents petal width. And the last one, which is our response variable column, it represents the category. Now, as we have discussed that in machine learning, it is necessary to split our dataset into training and testing dataset so as to get a better insight on the performance of our models. Now, to divide the data, I will use the group by function provided to us by Pandas Library, which groups our data by category, which means that on applying this function on our dataset, it will spit out three groups: setosa, versicolor, and virginica. And out of each such group, we will take first 30 rows for our training data and remaining 20 rows for the testing data. So in total, we will have 90 rows for our training dataset and 60 rows for our testing dataset. So I can say splitting our dataset into training and testing portions. So training underscore data. So I can say data, which refers to the entire dataset that we are having, and on that I can group our dataset. So let us group the dataset by the category, which is our response variable, and this will basically group our dataset into three categories, and from each category I want the top 30 rows, which I can get by saying head and pass on the number of rows that I want, which is 30. So from each of the groups that we are getting, from each of the three groups that we are getting, we are selecting the first 30 rows and we are making them as our training data. And to get the testing data, I can say data.group by category, and from each category I will be selecting the last 20 rows, and so in total you will have 60 rows. So 20 coming from your setosa, 20 from versicolor, and 20 from virginica. Now let us print the training data to the terminal. Training data. Print training underscore data. Let us copy this out, paste it down below, and change this to testing data. So testing, and now let us run the file. So here I will say Python sklearn Bayes.py, and now you can see we are getting our training and testing data being logged to our terminal. So we are selecting first 30 rows from each of the groups and we are using them as our training data, and the last 20 rows from each of our groups as a testing data. So now let us initialize our naive Bayes and the KNN models. So I can say initializing our classifiers, Bayes classifier, and I can say naive Bayes. And now let us initialize our KNN classifier, KNN, and this will take on the number of nearest neighbors that you want to use. So let us set that to a value of 5. So number of nearest neighbors. So now let us do the training of our naive Bayes and the KNN models. So from all the rows of our training dataset, let us select the first 4 cells from each row, which in this case is input variables or predictors of that particular row. And this is what we are doing for the entire training data that we got. And let us store that in train_x variable. So I will say train_x and then training data, and I can say ilog from all the rows of our training dataset, which is denoted by this colon. I want the first 4 cells of each row, so I can say :4, and this will select on the first 4 cells from each row, which is basically our predictors, and this will give us the training data or our training predictors. Next, for each row of our training data, let us select the last cell, which is the output response variable, and collect them in train_y variable for the entire training dataset that we made right here, and collect them in train_y variable. So we will have a collection of response variables in our train_y variable. So train_y training data dot ilog. From all the rows, I want the 5th column, which is denoted using an index of 4. So from all the rows, I want the fifth cell, which is this one, which can be denoted using the index 4, because we know indexing starts at 0. So this is 0, 1, 2, 3 and 4. And we are collecting response variable from each of our rows of the training data, and this will spit out the collection of our response variables for our training data. So now we are done with instantiating our classifiers. Let us fit them over the training data. So I can say Bayes Classifier dot fit train underscore x, train underscore y. So fitting our classifiers on the training dataset. Let us copy this down below and change this to KNN Classifier. So now we have fitted our classifiers on our dataset. Now let us grab our testing dataset predictors and response variables in the same way as I did for training data. So I can say, let us copy these two lines and paste them down below and change these four to test. So now we are doing the same thing for our testing dataset. And finally, let us fit our classifier on the testing dataset to make predictions for the unknown data points to evaluate the statistical power of prediction for our models. So to make a prediction using the KNN classifier, I can say making predictions using KNN classifier dot predict, and here I will pass on the testing dataset predictors, and together let us also make our predictions over the testing dataset using the Bayes classifier as well. So I can say predictions using Bayes classifier dot predict test underscore x. Finally, let us compute the performance evaluation metrics for classification for our KNN and naive Bayes classifiers that we just used for making predictions. So first let us compute the accuracy of our KNN and naive Bayes models. So I can say computing the performance evaluation metrics for our models. So first is accuracy. So I will print accuracy and let us say KNN, and here I will say accuracy score that we imported right here from our metrics module that is provided to us by the Scikit-Learn library. And to the accuracy score function, I will pass on my predictions using KNN and our testing dataset response variable collection like this. And let us copy this line down below and change this to naive Bayes. Accuracy score predictions using Bayes and the same testing dataset response variable collection. And let us give a new line here. Now let us compute the precision of our KNN and naive Bayes models. So I can say, let us copy this down below and change this to precision and this to precision score. And here we will pass on the predictions using KNN, then our testing dataset response variables, and then another argument which is average, and here I will set that to micro, and same here as well. So average, set that to micro. And lastly, let us compute the recall of both our models. So I will copy this down below and change this to recall and this to recall score. So this will be predictions using KNN. And now let us run the file. So we are getting an error. It says double underscore init double underscore got an unexpected keyword argument n underscore neighbors. Okay, so there is a typo right here. We need an h. Okay, so let us again rerun the file. So you can see the accuracy is 0.9833 for KNN and for naive Bayes it is 0.96. The precision for KNN is 0.983, and for naive Bayes it is 0.966. So for KNN the recall is 0.9833, and for naive Bayes it is 0.96. And you can see that we are getting high values for precision, recall and accuracy for both our models. And some of the reasons for this is that our iris dataset is a very simple dataset with relatively very less features compared to some bigger, messier, non-linear dataset. Also, its features are highly correlated with the class outcomes, and hence it is highly predictable. Now, because of this high correlation and similarities between observations, KNN does better than naive Bayes because it has an inherent nature to optimize locally, and also the decision boundaries that we get in case of KNN is much more complex than any other classifier, and hence you are getting more flexible classification performance. And this we have discussed in the video on KNN, so you can check out that video. So this was all about the video on implementation on naive Bayes classification and KNN algorithm on our iris dataset. So if you liked the video, do give it a thumbs up. Subscribe to the channel, hit the bell icon to get the notification for all the upcoming uploads, and I will see you guys in the very next one.